Good morning, pirates. Today we are going to work through a sample investigation, uh, learning the steps of the scientific method as we will write about and talk about them in this class. To do that, we're going to do a study on how the mass affects the velocity of an object. And we're going to use a simulator, which is linked right here. If you open that simulator, it takes you to the physics classroom, specifically an interactive called Push It. And I would go ahead and click and drag and make it a little bit larger. And then we're going to work on your Google Cloud copy of a slideshow. And so when you open that up, click on this blue link, you get this slideshow. Notice initially, if you look at the slideshow, the slides have little red pieces. The red pieces are where you will do your work. So that's where I'm asking you to change the slides somehow, and I'll kind of walk you through that. So let's first play with the interactive. It's called Push It. If you click Start, we are going to see how the mass affects the velocity of an object. We're going to keep the applied force, the surface friction, and the time are all considered constants, or things we will not change. So to use this simulator, you simply set your mass. We're going to start at 1, hit Push It. It plots it for you. Notice that you have velocities at 5 different intervals, and those velocities will show up on your screen if you click on the bullet, and so forth. So the velocity is 30 meters per second. The velocity is 50 meters per second. And so you'll want to keep time as a constant. So when you're recording your velocities, make sure you use the same bullet each time. So if you're going to use the 5th one, your constant time would be 5 seconds. It doesn't matter which one you use. So mass is 1 kilogram. My velocity is 50 meters per second. I reset my simulator, change my mass to 2, run the simulator again. Notice that my velocity has now decreased. Specifically, it was cut in half, 25 meters per second. Reset, change it to 3. Notice that my new velocity is 16.67 meters per second, and so forth. So this is kind of the tool that we're using to do our study. We're collecting data through this tool. On my slideshow, now let's think about how we might put this into the scientific method and writing up a report for this investigation. Our problem is, how does the mass of an object affect its velocity? That is our testable question. This is a link to that simulator again from your slideshow. The second slide asks you to write the problem here. So you're going to write this problem, how does the mass of an object affect its velocity, right here in red. To do that, you could just cut and paste it. Command C. Delete this. Command V. Change the color back to red. Select it, come up here, select red. Down here you have some notes. These are notes about how to write a problem or a testable question. It's written question using the format, how does the independent variable affect the dependent variable? Sometimes it's called a testable question. So on our next slide, it's actually asking for the independent variable with units, the dependent variable with units. So our independent variable is mass, and it's measured in kilograms. Our dependent variable is velocity, and it's measured in meters per second. Again, I'm getting that information from here: mass in kilograms, velocity, meters per second. So I'm going to continue through my slideshow. Notes about my variables: the IV and the dV should be taken right from your problem. How does the IV affect the dV? Our problem was, how does mass of an object affect its velocity? Next, we're going to write a hypothesis. I'm going to write my hypothesis here in red. A hypothesis is a testable answer to your problem. It's usually an if-then statement. For example, if the IV does this, then the dV will. I'm predicting the answer. Be sure to state how the IV will change. Don't just say if the IV changes. You need to say if the IV increases or decreases. And so I might write up here in red, if the mass of an object is increased, then the velocity will decrease. That would be my testable question's answer, known as the hypothesis. If the mass of an object is increased, then the velocity of the object will decrease. Next slide. Constants. Constants are things that we keep the same. They're the factors in the simulator that are unchanged. So if I go back to the simulator, I'm not changing the force. I'm not changing the friction. I'm not changing the time intervals. I'm not changing the surface it's sliding on. All of those things are the same. So I'm going to make that list in my slide for constants, and I'm going to do it right here in red. So my constants are the force, the time intervals, the surface friction, I might also say things like the temperature, etc. Typically, we'd like to come up with the 6 of these if we can. For the sim, though, you can just go with the factors that are right there. At this point, we're just learning the concepts. Next, we need to think about our control group. Our control group is the lowest measured independent variable. Higher masses are compared to lower masses, and so our lowest mass would be our standard. And so I believe that our lowest mass that we studied was 1 kilogram. And so the 1 kilogram mass will be compared to the 2, 3, 4, and 5 kilogram masses to see how it changed the velocity. Next, we have a data table. Some things about the data table. Notice our independent variable is on the left. Our dependent variable is on the right. Has a title, the effect of the IV on the dV. Down here is instructions. I want you to actually fill in your data table using the data from the simulator, and you're going to do that in red. And so I know that if I go to my simulator and reset it, I know that my masses are 1 through 5. So I'm going to go and put 1, 2, 3, 4, 5. And I recall from running the sim that my first velocity at 5 seconds, so I'm going to put velocity of object at 5 seconds, and it was 50. And then my 2 kilogram, the velocity was 25. And I will continue to run the simulator. So I need to know what it is for my 3. I push. My velocity is 16.67 meters per second. 16.67. And then I run it with 4, run it with 5 kilogram mass, and I come down here and I go ahead and change my color to red. Finally, I have some notes on writing a procedure. You should add a slide right here. Slide, new slide, and actually write a procedure. And your procedure would be step by step. How did you use the simulator? Here's the notes about a procedure. You are writing. This is either a numbered list or a paragraph, but your procedure should state how the independent variable will be changed or measured. Again, talk about the simulator and how you changed it. How are you going to measure the dV? Again, you're using a simulator. Where did you find it? And so forth. How are we keeping things the same? How many trials did we do? And then remember, the whole purpose of our procedure is to make our work repeatable. Don't forget to make your procedure in red. A good way you might test your procedure when you're done, have somebody else read it and see if they can actually use the simulator and get the same data as you did. The next slide is graphing. We're actually collecting data from a graph of the results. But if you were graphing this, you could take your data table here. You could set up your IV on the x-axis, your dV on the y-axis, and make a plot to show the relationship between the mass of an object and the velocity. We'll have more information about graphing later. But you should peek at the notes on graphing. Title, axis, scale, plot. Make sure you include units. Make sure you know when to make a line graph. In this class, we'll always make line graphs unless we have one variable that's not quantitative or numerical. Results and conclusion. Again, writing pieces. You're going to write your results here. I just need you to describe the data collected. So this could be 5 sentences or more. In this case, because we had 5 independent variables. So the object weighing 1 kilogram had a velocity of 50 meters per second. That could be your first sentence and so forth. Conclusion is where you actually state, hey, this is what I found. Go ahead and write a sample conclusion here. Once you're done, take a look at the expectations for writing a conclusion down here and use that to evaluate and improve your conclusion. When you're all finished, if you go back and open the assignment again in Canvas, go to Modules, this is called Inquiry Exploration Sim. When you open this again, you should have a blue Submit button over here next to where it loads your Google Cloud assignment. If you have any questions, shoot me an email. Have a good afternoon.